Okay, I think we're live. So, yeah, happy to be doing this for another day. Um, I think yesterday was pretty hype. Got it done with no real major problems. So looking forward to today. So I had a comment in one of my previous videos. Someone was asking what command I use to run my file on save. So you can see down here on my screen, it's intra is the command I'm using. -cc just clears my screen, clears the terminal before it runs the command, and then I just go run the thing. Because my folder structure is basically I just have a different file for each day, and so yeah, that's how I'm running it. Okay, here we go. The problem is up, so let's see how this goes. Lanternfish sounds interesting. The seafloor is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish swims past, and they must spawn quickly to reach such large numbers, maybe exponentially quickly. You should model their growth rate to be sure. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely, each lanternfish creates a new lanternfish once every 7 days. Of course it does. Why wouldn't it? However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, you reason, a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. Wait, a new lanternfish would need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. Suppose you have a lanternfish with an internal timer value of 3. After 1 day, its internal timer becomes 2, then 1, then 0. Then another day, its internal timer resets to 6. So it's 7 days, so 6, and it would create a new lanternfish with an internal timer of 8. After another day, the first is down to 5, and the second is down to 7. A lanternfish, so this is interesting because once it hits 0, it doesn't spawn, right? It only spawns on the next time step. So that's just one of those important things to keep in mind with these sorts of things. It's very easy to be off by 1. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included, just like I was saying. And a new lanternfish starts at 8. Realizing what you're trying to do, the submarine actually automatically produces a list of the ages of several hundred nearby lanternfish, which is my puzzle input. I'm just going to bring that up and see what it looks like. Cool, it's a single line. So that actually looks quite nice to parse, because then we can just go, let's say fish is going to be some ints, and then for each number in the input split on the comma, we just convert them to numbers, which is, these are the same functions I've been using every day. Oops. And we should have a list of numbers for all the fish. Perfect. Cool. What does it say now? This list means that the first fish has an internal timer of 3, the second fish internal timer of 4, and so on. Simulating these fish over several days would produce the following. Okay, each day a 0 becomes a 6 and adds a new 8 to the end of the list, while every other number decreases by 1, if it was present at the start of the day. In this example, after 18 days, there are a total of 26 fish. After 80 days, there would be a total of that many fish. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? That sounds quite straightforward to do. So I'm going to call this function step, takes in a list of the current fish, and it will return a list of the new fish. And I'm just thinking about how I might do this. I think we can just keep looping over the fish array, right? So because I'm going to be oh no, wait. You don't simulate the new fish that you append. Okay, so we need to say, we need to keep track of the new fish, which we will append to the end. And all the new fish will always be 8. So there's a couple of ways to do this, but I'm just going to keep appending 8s to new fish every time there is every time there's a new fish. So for every fish, what we're going to do is we're going to say if it is 0, we spawn new fish. Otherwise, we just minus, I think. So, and then at the end, what we want to do is we want to return append of fish with the new fish. So here we need to spawn a new fish. So new fish is going to be just a new fish with 8. And the current fish resets to 6, right? Like this. So I think this function should simulate 1 day. We can try this out just by kind of doing this and comparing visually the output. So we see that 1 goes down to 0, 3 goes down to 2, and so on. Okay, so no fish starts off at 0, so I'm just going to do one more step just to kind of visually confirm that we're spawning new fish. There seems to be a decent number of zeros. I'd say about a third of each, just visually, a third of each line is a 0. So we should be appending about 3 lines of 8s. We are appending about 3 lines of 8s. So that looks kind of correct to me. So we're just going to do this. Wait a second. How is this affecting my original array? Right, because I'm appending to. Ooh, okay. This looks a little sketchy. I should be reassigning this. So we will do that. So 80 days, right, was the question. Fish equals step fish, and we want to count how many fish we have on the last day. So len fish. Shouldn't take too long. So apparently I have that many fish. I'm going to try it first. I might be off by 1, but I don't think I am. There we go. Perfect. So suppose lanternfish live forever and have unlimited food and space. After 256 days in the example above, there'll be a total of that many lanternfish. How many lanternfish would there be after 256 days? So I'm going to guess that this doesn't run, but it might just run. So I'm just going to do it and let it go and see what happens. What would be a smarter way to do this? A smarter way to do this would be to keep track of the number of fish. I'm just going to let it run in the background because it's probably going to run faster than I can implement an efficient solution anyway. So as it's running, I'm going to think about how what might be a more efficient solution to this. Hey to all the people in the chat, thanks for joining me. So what we should be doing is keeping track of the number of fish in each day, right? Rather than actually having an array of all the fish. I have to be careful about saving this file as well because it's going to rerun, I think. And I don't want it to rerun because I'm going to lose whatever the result is. So I'm going to make a new file, actually. So I'm editing the new file. So just in case that actually finishes, I'm not going to lose my result. Gonna let that run. Let's make another split here. Cool. So instead of running this many times, which is a bit silly, we are going to keep track of the number of fish in each day. That should be quite straightforward, right? So this is going to be an array of size size 9 because they're up to 9 days for the fish, right? And then for each one, instead of appending it, we're just going to say that value in the array increases by 1. So we're using a different data structure here. Hopefully that makes sense. This means that there are, I'm just going to take a look at my input just to be sure. Yeah, so this means there are 110 fish on day 1, 50 fish on day 2. I mean, that kind of looks like 50. I think that's correct. And so on. So now our step function looks a bit different, right? Our step function now is going to be, we're going to say, let's see, we're going to need a new array. So new next is going to be still going to be an array of size 9. Then we're just going to say that for each number from 1 to 8, so for I equals 1, I less than 9, I plus plus, next I minus 1, so next 0 is fish 1, right? Hopefully that makes sense. And then we're going to say next 6 plus equals fish 0. We're also going to say next 8 plus equals fish 0, return next. And I think that should work. In fact, what we can do is we can run this 80 times now. Fish equals step fish. Then we're going to print fish. If we add all these numbers up, and I'm just going to do that off screen. Oh, okay, we ran out of memory. I'm just going to do this off screen in a calculator. And the number comes out to, according to my calculator, 360,268, which I believe was my answer to the previous one, 360,268. Okay, so this works for 80. I'm going to try it for 256. It should just give me an answer straight away. Oh, I got to add it all up. So yeah, good old summing things up in Go. And we're just going to print that number out. It's going to give me a really big number, but I'm pretty sure this is a correct number. I'm going to pop it in here and got it right, 750. Okay, yeah, it was a cool problem. And I really liked how they kind of stepped up the difficulty, right? The first part, you could do it the naive way and actually just maintain a giant list like they suggested in the worked example. Clearly that worked for small enough input. But once you got into big enough fish, right, and it kind of suggested that they grow exponentially, which they do because you're adding day 0 back into the list twice. That grew too quickly for you to be able to do it the naive way at 256 days. And so you had to work out a different data structure in order to be able to keep all that information and still be able to compute the result. And so just by changing it up to a different way of representing the fish, you could do it a lot more efficiently. Now, I'm sure that this isn't the most efficient way to do it. And in fact, you might even be able to come up with a formula, maybe, for how to work out the number of fish on a specific day given the signing days, just because the numbers basically just keep cycling through the array, right? But at a certain level, for me anyway, implementing a relatively, like this, I think is like level 1. If the first solution was like the naive one, this is like the next step up in terms of naivety. Right? It's not, I'm sure there's going to be an even better way to calculate it, but this way clearly works. And yeah, got an answer. 750 is actually not that quick for the amount of time I think we spent on the problem. Yeah. So I think not too many people are having problems with this either, which is fine. So yeah, um, it's a really cool problem. I don't really have too much more to say about it, and so I hope you enjoy the problem as well if you are doing it or have done it as well. And hope to see you again tomorrow. Thanks for joining me.